Good evening. So today, in continuing with the system boundaries and system interfaces and stuff like that, we are now looking into the today's component system interfaces and interactions. And today, this is the 11th lecture of systems engineering, and I am Dr. Deepak Philip from IIT Kanpur. So we talk about interfaces, and we have been already seeing this term interfaces, and we also heard that interface is the responsibility of the systems engineer. So what are interfaces? So let's define interfaces. So the system, if we write it, the system interacts with external environment we know where does it interact? It interacts at various system boundaries, okay. And where is this boundaries? It is at system and its environment. So then these places where the system and its environment where it interacts at the system boundaries, they are called as external interfaces. So the external interfaces are those locations at system boundaries where the system interacts with its environment. So the external interfaces is where the place where the system is being interacted, the system interacts with this environment. So now the thing is, the systems engineer, the SE, the systems engineer, is supposed to know, or he knows, or she knows both system and the environment. So since the person knows system and the environment, hence the definition and control of external interfaces or interfaces. Let's talk about external interfaces for the time being. Interfaces are the responsibility of SE. So since the systems engineer knows both system and the environment, and he knows the system and its environment, then he is supposed to, or she is supposed to manage the definition and the control of these interfaces, so that the system can interact properly with its environment. So these interfaces can be managed, and the management of these interfaces is the major responsibility of the systems engineer. So this responsibility, the major responsibility of the systems engineer, it has two parts. The part one is identification and description of the interface, and two is the coordination and control of the interfaces. So the identification of the identification and description of the interfaces, this is part of the system concept definition. So what do we do here? So when you have the systems concept definition, this identification description of interfaces is one of the major part that the systems engineer is supposed to do. So or the way he or she manages the interfaces. The second is the coordination and control of the interfaces. So what is it amounts to is, it is to maintain system integrity at all times, or the better way to say it is, when at the time of engineering development engineering development. The other one is also the production or manufacturing of the system. Then is also the performing enhancements. So, the coordination and the control of the interfaces is necessary because it helps the systems engineer to maintain the integrity of the system at all times, whether it is at the development of phase of the system or the production phase of the system or performing enhancements or maintenance of the system. That is also important to this. So, we just saw how the system interacts with the environment and what we talked about what is external interfaces. So, then what are internal interfaces? Should be the interfaces inside the system. So, the internal interfaces can be better defined as the boundaries between individual system components result in internal interfaces. So, here the individual components of the system are interacting. So, if you have looking at here, it is like the system and the environment is interacting. So, doing different type of interactions. This is the environment if you think about it. So, this is the external interfaces, whereas if you think about this, you have system has multiple components in the system, and when they interact, then that is called as the internal interfaces. So, this is the system and this is also the system. So, the external interfaces are always with the environment, system environment, whereas the internal interfaces are always within the internal components or individual components of the system. So, whose responsibility is the internal interfaces? The internal interfaces is the responsibility of the systems engineer. External interface, it is the responsibility is systems engineer for sure. We already told that because he is the only person with the knowledge of both system and environment. So, then whose responsibility is the internal interfaces? It is again systems engineer. The responsibility is with the systems engineer. Why? Because the individual components, if you look at it, I am just kind of writing it this side, the individual components responsibility. Who has this responsibility? It is the specialist. So, the specialist is responsible for the internal components. So, when two separate specialists are in looking after two different components, then the interface is always the responsibility of the systems engineer, because in individual components being the responsibility of the specialist engineer, and the internal interfaces becomes the responsibility of the systems engineer. And then we now talk about stuff called interactions, and interactions are quite important in this case, because system element interact using interfaces, and system also has what you call as the systems maintenance interactions. So, let us talk about system how does the system elements interact using the interfaces. So, we can say that two system elements interact with each other, how do they interact with each other? Through interface connecting them. An example of this is the way you can think about it as an example as a steering wheel. It is the interface between, what does it do? Here you have the operator's hands and vehicle wheels. So, the hands and the wheels, the operator's hands interact with the wheels using the steering wheel. So, this is the example of how two system elements interact with each other, and you can assume that the steering wheel is the interface that is connecting them. So, let me give you another example, and this interaction through interfaces is quite complex, can be depending upon the type of system that we are looking at. So, one example is, let's take because you have been talking about this UAV as an example. So, let me draw a simple UAV. It's kind of a box, and I am giving a example of a tail. We are talking about a vertical fin, which is called as the rudder. So, we are talking about this. Okay, we are talking about the rudder of the UAV. Okay, it has its wings and stuff like it's flying around. Okay, and the rudder is controlled by, like from the ground. Let's say you have a human being who controls a stick, which is mounted onto a box, and it is connected to a antenna, which is mounted on a tripod. Okay, and the user moves the sticks. So, let us call this as the control stick. Okay, and this movement is captured by, there is a computer within this, or a mechanism that converts. What does it converts? Converts the stick movement to signals, and that signals then goes to this base box, and then the base box transmits the signal to the UAV, and UAV has an antenna. So, here is the antenna, and it captures the signal, and it sends a signal to control. So, let us call it as a UAV control. Then this control has a connection to a motor. This is mounted here, a servo motor. This is the servo motor. So, depending upon the level of movement of the stick, so level of stick movement is translated to rudder movement. So, if the person moves the stick by, let us say 1 degree, 1 degree stick might be equivalent to 3 degree rudder, 3 degree left rudder or 3 degree right rudder. So, somewhere it is calibrated accordingly. So, what I am trying to say here is that this interface, so by moving the rudder 3 degrees in one direction or other, you will end up yawing the plane, the left or right, depending upon which way the plane, the UAV. So, depending upon the rudder, which it will allow the system to move this way or that way. So, the system diagram would probably look quite simple like this. It will look this as the move rudder is the function, and here what happens is rudder deflection is the output, and this will be the rudder input. So, the control stick input happens here, and this whole mechanism what we just wrote about, all these things up to here, kind of goes into this box, says, and then it translates into the deflection of the rudder. So, one of the aspect is that, and one aspect of this whole interaction is that it appears quite simple in a diagram, but it is not really simple. It actually has quite a lot of parts that allows the system elements to interact using interfaces. So, the interface design, and studying the interactions is quite important for successfully engineering a system. And also another aspect of the interaction is the maintenance interaction that the system can have. So, it is an important interaction, but very less or less adequately addressed external interaction. What is that? the system maintenance. People does not really pay much attention to this one when you are designing the system, because at the time of maintenance need to access system functions for testing purpose. People might have already seen that many vehicles like BMW, Mercedes and all, they typically have a mechanism where you have a car, the car is you taken to a workshop, you have the four wheels, you taken to the workshop, and you have a computer here, you take a cable, connect to the computer, and the computer tells what are the major issues with the car and then what all corrections need to be done. And this diagram looks ugly, but still gets the point across. So here this is where you are accessing the system, the car is the system, and this computer is used to conduct the or test the vehicle functions to do maintenance. Another simple example of this is the dipstick for checking engine oil. So that is also one way of interface through which you can interact with the condition of the engine oil of the system to figure out how good the condition of the oil is, and you can change it, or you can use an advanced system where it can directly access this. So some people do consider that automotive vehicles that are capable of doing this particular case is well engineered systems, because they are also thought through the system maintenance, which is usually less adequately addressed feature in the interfaces and interactions design. Now we talk about the elements of the interface. So we know that the interface is at where the interactions happens, and interface is something that is integral to the system. And there are three different types or three different aspects that actually helps us to distinguish internal and external elements and internal and external interfaces. So the first one is the connector, second one is the isolator, and third one is the converters. So what are these? So the connectors, in a simple definition, they are the ones that facilitate transmission between components. Whose components? System components, or it can be also the external also. So here an example would be, some of the examples will be transmission of electricity, which is the power. It could be the transmission of fluids, which is material. It could be the transmission of force, or it could be the transmission of signals. These are all connectors, etc. So these are examples of connectors. So what it does is it facilitates transmission from between components. So it's moving stuff from one component to another. Second one, isolators. So what do isolators do? They do exactly the opposite of connectors. Or what it is that inhibits the flow of interactions. So some of the examples of this would be like RF shield. So they stop the radio frequencies. Then shock mounts. The aim is to isolate shocks. Then seals to isolate dust, grim, oil, stuff like that. Cover or protective casing, etc. These are examples of isolators. And the idea is to inhibit the flow of interactions. Third one is the converter. And what are they? The converters. Converters alter the form of interactions, interaction medium. So they alter the form of interaction medium. What does that mean? These are interfaces that are embodied embodied in component parts or subcomponents, and they are considered like interface elements. Okay. Some examples of them are antenna. This is where an electrical signal is converted to RF signal, for an example. Gear train, a motion in one direction is translated to a motion in another. Piston, it converts thermal to mechanical energy. Keyboard, okay, a hand motion to text, something like this. Okay. So, these are all converters, they alter the form of interaction medium. So, you kind of start in one medium and then you end up with some other form. So, where it interfaces with the, it is usually embodied as the component part. Like for example, piston is an integral part of the engine itself, which is actually used to convert the thermal energy of the fuel to a mechanical energy, the harmonic motion of the engine. So, the so with these interface elements, there are few considerations. The one of the major considerations that we need to think about here is the make or break the connection between two components. So, the interface elements either do make or break the connection, and this is very important because this is part of the system control design feature. So, if there is some issue, you should have a mechanism to make or break the connection. So, like for example, clutch is an example, whether make the connection between the engine and the transmission or break the connection between the engine and the transmission. So, that is one part. Then the another aspect of it is, part 2 is that connecting non-adjacent parts. They are not next to each other, and these connections are through cables, wires, etc., like insignificant components, is usually not part of any particular system component. So, if you have two computers in a place, you have a computer 1 and a computer 2, C1 and C2, and you are connecting each one of them using a LAN cable. So, then this would be a connecting non-adjacent. So, let us say this is in one particular room and this is in another room. Let us say if you assume it that way, you are connecting them. This connection is not really part of this interface cable, is not really part of any system as such, and you do not really design that as part of the system. But it is critical because you need to pay special attention, because if this connection is not done properly, then the interaction of the system, that both the computers will be hampered. So, exactly the same way, when you are connecting non-adjacent parts through cables, wires, which are not part of any particular system component or does not been designed as part of the system, then you have to pay special attention. That is also one other consideration. And the third one, the most important one that everybody should think about at this point is, I am writing it on the top here so that we can remember this as an important aspect of the system design. The third one, most important one, is that large fractions of system failure occurs at interfaces. occurs at interfaces. This is quite important, you know. So, then because of this you have to assure or ensure high interface compatibility. You have to ensure that high interface compatibility is one aspect of this, and you have to have the reliability also. And whose job is to do this assurances? Systems engineer. So, if a system fails at the interface, then, and most of the systems do actually fail, large fractions of the system failures, this everybody should remember, occurs at the interfaces. And to prevent that, you should ensure, the systems engineer should ensure and assure high interface compatibility and reliability of the interfaces. Now, one of the things that we saw so far is the concept called systems of systems. I kind of briefly mentioned this in earlier presentation, and we said we actually will see this later down the road. And the origin behind the systems or system of systems or SOS usage is quite simple. Of late or lately, of late, single systems are integrated to be part of a large entity. I kind of draw an example earlier in the one of the presentation that where you have AWACS controlling UAVs, fighter jets, and as well as field guns. And surprisingly, lot of these definitions actually came from, this definition of the systems of system came from US DoD. This is United States Department of Defense. So, the DoD definition is quite simple. What it says is, it is a set or arrangement of systems. So, it is a setup or arrangement of systems that results when independent and useful systems are integrated into a larger system that deliver unique capabilities. So, if you think about it, in the previous example that I was talking to you, let us think about a system where a UAV which is independently capable of surveillance, and a fighter jet, it is capable of delivering bombs, let us say payloads, but we will use bombs, and let us say a soldier, okay, and who is capable of using wide variety of weapons, something like this. So, let us say you are integrating this in a battlefield. So, you could use UAV to, so let us say you have a UAV standing here, and there is a tank sitting here, the enemy tank sitting here, and you can use the UAV to designate this using a laser targeting, and a fighter jet which can come from here and then drop a bomb which will actually come and hit the target. So, for this the UAV need to communicate with the fighter jet, and as well as this, the ground force that is moving forward need to know that the fighter jet is coming to destroy the enemy tank. So, they have to find cover to ensure that this explosion does not hamper them, this kind of a stuff. So, everybody need to have information passing back and forth. So, these are, think about this as the fighter system, this is a surveillance system, there is a human based system, here is a enemy, a tank system, a land based system. All those things can be somewhere interact to deliver something that is larger than the current capabilities. So, that kind of a system usually originated from warfield or battlefields, and then now it has been used in many capabilities. So, there are many ways you can discuss about when a system becomes a system of systems, or when systems integrate to become systems of systems. So, let us look at 4 of these cases and see how they are worked. The first one we talk about is the virtual one. So, the virtual systems of systems. These are, you can all read as systems of systems. The virtual SOS, they lack central management authority and a centrally agreed purpose. So, sometimes the few countries or few agencies within the country might collaborate on a specific inquiry of a case or a crime, and they will come together informally, virtually at the time period. They will all work together to crack the case, and when that case is over, then they go into their own way. So, what happens here is that this means such systems will rely on invisible mechanisms to maintain large scale behaviors, because all these systems that we talk about, they are independent, and they don't have there is no central management authority, and there is no centrally agreed purpose. But for some specific reason, for some invisible mechanisms did exist, and the systems started collaborating with each other. And when the invisible mechanisms goes away, then the virtual systems or systems is typically seen to be collapsing. So, the second one is a collaborative systems. So, what is a collaborative system? So, here the components of the system, the components of the system, the components of the system interact voluntarily to fulfill agreed central purposes. So, in this case, usually people agree on making something, and there is a agreed central purpose is that components of system do interact voluntarily to fulfill the needs. But, and usually in many cases, the standards are also adopted. But no central authority to enforce these standards. So, like an example of this is an open source software system where people collaborate with each other, and there is a common centrally agreed purpose, and everybody works voluntarily towards it to fulfill the agreed central purpose. And some standards are also agreed upon, that we will do this, we will do that. Some standards are agreed upon, but there is no central authority to enforce those standards. So, that is the collaborative system. Then we talk about is the acknowledged system. So, the acknowledged systems, they have recognized objectives, designated management, and dedicated resources to do what? To fulfill the agreed central purpose. But the major aspect of this is that constituting systems retain their independent ownership. So, a classical example of this is that special operations, people from different fields do collaborate in this, like people from Air Force will be the ones who will be flying the operators from place A to place B. Operators might be drawn from different areas of Army, Navy, Air Force or stuff like that, and they collaborate together, and there is a designated management, and there are designated resources. All those things are part of this, but at the end of the day, they still maintain their independent ownership. The aircraft still might belong to the Air Force, the soldiers might still belong to Army or Navy, something like that. So, all those kind of stuff. So, the acknowledged systems are, to a large extent, they do have recognized objectives and designated management and dedicated resources, but they still maintain their independent ownerships. So, this brings us to the last one, which is called as the directed systems. So, what is a directed system? Because of the lack of space, I will try to write on the top of here. A directed system is a integrated SOS, system of systems, that is built and managed. We are talking about this, built and managed to fulfill a specific purpose. So, the importance here in the directed system is that it is built and managed to deal with a very specific purpose. So, here the interactions are complete or dedicated. So such systems are tightly coupled also, or such systems are tightly coupled to create what we call as a system of systems. So, with this we have come across the major aspects of system, its environment, its boundaries, its interfaces, the context diagrams, and how interactions happens, and what are the ways in which systems of systems get defined, and other aspects of it. So, now since we now know how to define the environment of the system and the boundaries, and as well as what are the different aspects that can create a input to the system, and how does the input gets translated to a necessary output or a useful output, that is that's the main aspect of the system design. So, the tools that will help us to define the system, describe the system, and as well as come up with other aspects that is necessary to do the design, production and management of the system, we will start seeing them from the next classes. Thank you very much.